I'm going to work just a couple of problems for you that are similar to the ones that were on your homework for this weekend. And this video assumes that you are familiar with the ideas of simplifying a radical expression and that you are familiar with the idea of why you might use absolute value bars to simplify an algebraic expression. If you do not know anything about those two things, please make sure you go back and look at a couple of the previous videos that I've made, because I'm going to operate under the assumption that you know. These are strictly to give you some practice so that you can try to work them out, then pause the video and restart the video and try to check your work. So if I were you, I would take a moment and pause the video. As you can see, I'm going to write this just a little bit bigger. We're looking for the fourth root of 625, x to the 28th, y to the 32nd, and we're looking for a way to simplify that expression. So you pause the video, try to work it out. I, on the other hand, am going to go ahead and work it. So I know that the fourth root of 625 is 5, because 5 times 5 times 5 times 5 gives me 625. So I'm going to rewrite this expression with the 5 kind of jailbroken outside of the rest of that radical. Now, I don't know why my 2's keep looking like 7s. Sorry about that. And the reason that I use just the positive 5 is because in our original problem there is no negative out here, which is implying that they want the positive square root. Remember that every even-numbered root has 2 roots, both a positive and a negative one. The fact that there's no negative out here implies that they're asking for the positive root. So next, I can sit here and think to myself, all right, x to the 28th, y to the 32nd, if I raised both of those to the 1/4 power, which is what would happen if I'm using the fourth root, they come out nice and evenly. Because using my product of a power rule, or raising a power to a power, 28 taken to the 4th power would be 28 times 1/4, which gives us x to the 7th. 32 times 1/4 gives us y to the 8th. So I can finish it up by writing 5x to the 7th, y to the 8th. Now I need to go back and see whether or not I need to deal with absolute value bars. Now, since it's an even-numbered root, again, there's really a negative version and a positive version of this root. And I need to ensure that I'm explicitly saying I want the positive version. 5, I've established that I want the positive one because I just didn't put a negative in front of it. Y to the 8th will always be a positive because let's assume for a second that y itself happens to be -1. Well, if I multiply -1 times itself 8 times, say 1, 2, 3, 4, 5, 6, 7, 8, each pair of negatives is going to cancel each other out, so I'll be left with a positive regardless. So because that 8 exponent is even, I know that I can just leave it no matter what y happens to equal. Y to the 8th will always be positive. However, x to the 7th, because that is an odd-numbered exponent, if x happens to be -1, and I multiply -1 times itself 7 times, those will cancel, and those will cancel to a positive, but I'll still be left over with a negative. So just in case x happens to be a negative number, I need to put the absolute value bars around it to imply that I want the positive version of that x to the 7th. So therefore, my final answer should be B. Here's another one, very similar for you. The fourth root of 81, x to the 20th, y. Achoo. Oh, excuse me, I just sneezed. Y to the 32nd, sorry about that. I'm now going to take the fourth root in order to simplify it. So 81, the 4th power of 81 is going to be 3, because I know that 3 times 3 times 3 times 3 is 81. So I'm going to jailbreak that 81 by fourth rooting it and making it a 3. And I'm going to make it the positive 3 since there's no negative out here. That is implying that I want the positive root, not the negative root, as all even roots have. Then, because we've got x to the 20th and y to the 32nd, if I raise those both to the 1/4 power, they'll come out nice and evenly, because 20 times 1/4 is x to the 5th, 32 times 1/4 is y to the 8th. Just like in our last situation, we've addressed the issue of whether or not I want the positive root with the fact that this 3 is positive. Anything to an even-numbered exponent, no matter what y happens to be, will always turn out to be positive. However, since this is an odd-numbered exponent, if x happens to be a negative number, then we need to be sure that we put absolute value bars around it because we want whatever x to the 5th power is, we want the positive version. Therefore, our final answer is going to be A. And here's our last example of the day, the cube root of 343, x to the 15th, y to the 12th, and I'm going to take the cube root of that. So 343, I just happen to know, 7 times 7 times 7 gives me 343. So I'm going to get that 343 out from underneath that cube root. So that is going to leave me with the y to the 12th and my x to the 15th under the cube root. We know that if we take x to the 15th and y to the 12th and raise it to the 1/3 power, taking our power to a power, 15 times 1/3 will give us x to the 5th. Y to the 12th times, or raised to the 1/3 will give us y to the 4th. So we have 7, x to the 5th, y to the 4th. Now, because our original problem started out as a cube root, this time we don't even have to think about absolute value bars, because you'll recall from the previous video that every even-numbered root has a positive and a negative version. But every third root only has one cube root. So therefore, we don't have to worry about differentiating between whether we're looking for the positive or the negative version here. So it doesn't matter whether x to the 5th turns out to be negative or not. So we can actually just leave this at 7x to the 5th, y to the 4th. So our answer should be B.